Okay, good morning everyone. Today is the 19th of May. First lesson for full HBL. We are going to do A Maths calculus. Calculus involves both differentiation and integration. All right. Now, for the next few days, I will be focusing on this same topic. Okay. Because for calculus, the questions can be divided into kinematics, all right? Within kinematics, you can have differentiation and integration, okay? Also, you can be asked to find the original y equation given dy dx. Okay, as you know, the two processes, differentiation and integration, they are reverse processes of each other. Okay, so you can actually use differentiation and integration for such questions. So this will form like one question. This is another question. And the other question that you'll get in the O levels is this. For the first part, they will ask you to differentiate a certain equation or expression. After that, they will say hence. Hence meaning you use the result from here to integrate something. All right. So that forms another kind of question. And the next one will be finding area using integration. And lastly, techniques of integration. This may not be a standalone question, but I just want to focus on this because this is so-called the first lesson of integration. Previously, we have only been doing like differentiation for our exam topics. Okay, now for the next few days, I will still be doing these few topics because these few, this 1, 2, 3, 4 especially, will so-called form one question in the examination. All right. So the level of difficulty will increase as we go by. So if you have any question, you don't understand this first lesson, please ask me. If I'm going too fast, please just PM me to let me know. I will be sending you all the notes that I'll be going through, all the questions I'll be going through with you. So not to worry too much. Now let's start things off. Most of you already know that differentiation, integration, they are reverse process of each other. And if we were to look at this first question, where you are asked to differentiate this expression. Okay, for example, you're given 5 over square root x. You're asked to differentiate this. Do not use what do you call that? Quotient rule. There's no need to. If you want to, you can, but actually there's no need to because you can simply rewrite this as 5x to the power minus half. Okay, using your indices law, whatever you've learned in E-maths. Now, after you've done this expression is simply ax to the power n. Now, ax to the power n is very easy to differentiate because what you need to do is simply multiply this whole thing by the power and then minus the power minus 1, correct? That was what we have been learning so far. And what you end up with is this. Okay, so multiply by the power and take away 1 from the power. Okay, and what you end up with is this expression here, minus 5 over 2. And this minus means that this x would be in the denominator when you change it to positive index. 3 is just power 3. Denominator 2 means square root. Okay, now if I were to similarly ask you to differentiate these other two expressions, one of them is the same thing, plus 7. The other one is the same thing, 5 over square root x plus 3. You will find that if you were to use the same process or same method, you will end up with exactly the same answer. Now, why is that so? As we have discussed in class, As we have discussed in class, can be written as 3 times x to the power 0. So when you multiply by the power, multiply the power, that's the first thing you do, right? The whole thing actually disappears. So your final expression won't give you a clue as to what the original number is here. Of course, the original number could have been 0. We don't know. We will never know, you see. All right. So That is the reason why when we integrate, integration is a reverse process of differentiation. When we integrate, right, we always need to put a plus C, plus C, plus C, because we don't know what this C originally is. It could have been 0, it could have been a number which we don't know. All right, so that explains why there's a plus C when we integrate. Okay, I hope that explains it. Now, I've written here the steps involved in differentiation of expressions of the form ax to the power of n. Okay, a meaning in this case is 5 lah, 5 x to the power n, right, is x minus half. So minus half is your n. Okay, we know how to differentiate such expressions. Power, you multiply by power, that means multiply by n, and then the power minus 1, and you multiply by the differentiated fruit. Differentiated fruit means what? In this case, because it's so simple, right, so it's just differentiate the x. But sometimes it could have been bracket, later you will see bracket, then 2x plus 1. Then you have to differentiate 2x, right? Then you will have to multiply by 2. That's what I mean, okay? Yeah, so these are the 3 steps involved in differentiating this kind of expression. All right? Now that you have understood or record this, now let me go to the reverse process. Meaning to say that if I were to ask you to integrate this instead, meaning I want you to get back this, right? So assuming you don't know what this is originally, it could have been this, could have been this, could have been this, right? So what do we do? As we have discussed, integration is the reverse process of differentiation. Okay? So if I were to go backwards, I have to start from number 3, right? So instead of multiplying by the differentiated fruit, I have to divide. Okay, same thing, you write as ax to the power n first. So I have to divide by the differentiated fruit. Okay, then the next step is, instead of the power minus 1, I have to power plus 1. Alright, and lastly, instead of multiplying by the power, I have to divide by the power. So I hope you can see, going this way is differentiation. But if I want to integrate, alright, if I multiply here, I have to divide here. If I minus 1 here, I have to plus here. If I multiply here, I have to divide here. So it's a reverse process, and that explains why our working is as such. Okay, so let me just recap with you, just in case some of you have forgotten. So you have this expression, right? Rewrite it as ax to the power n, because this is a form that you know how to work with. Alright, now firstly, see whether there is the fruit, you need to differentiate. Okay, so no need, right? No need. So not say no need lah, you actually differentiate this and then you get 1, then you divide by 1, no need to write lah. So this step is not necessary here. Okay, now what is the next step? You need to plus 1 to the power. That means you plus 1. Minus 3 over 2 plus 1, if you don't know, you press calculator, it's minus half. Okay, and the final step is divide by the new power. The new power, okay, not the old one. The new power, which is this, the one that you see at the same step, you divide by it. Okay, and you need to plus a C. Why? I've already explained here. Okay, because you don't know what the original number is. So your final expression, those of you not very good at manipulation, you just press calculator, okay, minus 5 over 2, then put at the denominator minus half, you will get 5. Yeah, you see, it's exactly the same as what we have started off with. Yeah. Okay, so I hope that explains. Okay, so this is the basic. You need to know this basic. But of course, in the exams, normally we would give you maybe something like that, slightly harder. That means you have to differentiate the fruit. I hope you can see, and I hope you all know what I'm talking about when I say the fruit. Meaning this is the shell, right? The square root and the square here, the bracket, is the shell of the durian. The fruit is, or are the 5 minus 4x inside. Okay? So let's see how we do it. Now, for this, right, if you are asked to differentiate, uh, there's no need to use a quotient rule. But if you want to, you can use, okay? But the easier method is to change this to ax to the power n. You see, the denominator power, right, will be 2, that's 2, over 3, okay? Remember the root is just the denominator, okay? And then when you bring it up, you have a minus here, that's all. So it's written now in the form, it's still y, I've not done any differentiation yet, okay? No differentiation at all yet. I'm just doing makeup, rewriting this in the form that I can easily work with. Okay, now, after I've done this, same thing, it's actually a x to the power n. So, n bring down, meaning multiply by the n, okay? This remains the same, this remains the same. The power, go and minus 1. You press calculator, you'll get this. Now you must differentiate the fruit, which is 5 minus 4x. 5, you differentiate 0. Minus 4x, you differentiate is minus 4. So you need to multiply by this. So this is the step, you see. These are the steps. And then, okay, the numbers here. Alright, those weak in manipulation, please just press calculator. You will get 56 over 3. Okay, and this minus means it's at the denominator. 3 means root 3, 5 means power 5. That's all. That's all for your differentiation. Alright, so if you notice this 1, 2, 3 steps exactly the same as the previous question. Now, if I now were to give you this, meaning this, which is dy dx, and then I ask you to integrate this, meaning I want the original expression here, what should you do? Again, rewrite this in the form that you can work with. Okay, I'm writing this just for your information. You see dy dx, right? When I integrate it, right, the way to integrate is this. The operator for differentiation is d dx, right? The operator means like plus, minus, divide, times, bracket, all that. Operator for differentiation is like that. Okay, in between, of course, there's something. It's like that. Okay, so meaning to say you want to differentiate something, that something will be in your bracket here. You want to integrate something, that something will be here, the space here. So if I were to write, or if I were to integrate this, integrate means write this integral sign, then got the dx here, right? Don't you agree this and this, sorry, this is one pair. This and this will cancel each other out. So if I were to integrate dy dx, you see, this is a pair. And this, as I mentioned to you, is an operator, right? So they cancel each other out. So your result is just a y. Okay? This is just something for you to take note lah. Okay? Now, but you don't have to write this. You don't have to write this. That means straight away you want to integrate this, right? You can straight away write y already. No need to write that. I written this here just to explain to you what's going on here. Why suddenly like that then disappear? Okay? It's due to whatever I explained in the previous sheet of paper. Now, if I integrate this side, I must integrate this side, right? So the operator is like that. Integrate with respect to x. Okay? If you want to integrate with respect to t, then you change it to t. With respect to z, then you write z. Okay? At higher level, this will change. In fact, when you do kinematics, this will be normally dt. Okay? Because we are integrating with respect to time. Okay, now, again, this is not in the form that we are familiar with because we don't know, or we don't have any like quotient rule, product rule in integration. So what do? We change it into form a x to the power of n. And your this x is like a big X like that, like your linear law, the big X, but actually it's a fruit, right? So I rewrite as a, the number, a is just the number, x is this big fruit lah. The fruit inside this is a shell to the power of n. So take note 5, you just write 5. The root 3, just write the denominator. Then because you are bring it up, so there's a minus here. Okay, so now it's become a form a x to the power n. Yeah, we can now use this reverse process. Okay, go in the opposite direction. All right, and then you can get the answer. Okay, so what we do is, just now we multiply by the differentiated fruit, right? So now we have to divide by the differentiated fruit. So what is the differentiated fruit? The fruit is this one, right? So you differentiate this, is minus 4. So divide by minus 4. You see, your this is just the same, right? So I'm just starting to differentiate now. That's why once I start to differentiate, I don't write this integral and the dx sign anymore, okay? I differentiate this, I get minus 4. Then power plus 1 here, okay? Just now was minus 1, right? Now plus 1. Okay, and finally, divide by the new power, which is this. All right? Okay, now, you can press calculator and you will find that your answer is going to be this. 7 over... Yeah, okay? So I think that it should be clear to you. But you need to put the plus C. Why? Because you don't know whether the original expression has a constant here. We will never know, okay? Because the question won't tell you, oh, original one is like that. They won't tell you, okay? So I hope that is clear. Okay, now, we are done with the basics. We are now going into the actual questions that you will see in your examination. Okay, so we will start with area. Let me see how much time. Oh, 15 minutes already. Okay, so area. Let's say you're given this question, a question like this. Okay, you have your x and y axis, and you have a curve that goes this way and is defined by y equals x bracket 6 minus x. So you can see there that it is quadratic and it's a set face, right? So you see, when you do questions, you must have this sense of awareness. You must know what's going on. Don't do things blindly. Okay, so set face, okay, and then there's a straight line, okay. Then they want you to find the ratio of area of B, area of A, which is here. Okay, I cannot shade because yeah, I want to do something here, so I don't want to shade lah. But this is A, okay. B is this part here. Okay. Okay. So A is this, B is this big part here. Okay. Now, if you remember in class, right, I asked you to imagine that you are walking, okay, from here. Okay. Let's say now I want to find A. You know, right? I have to find area of A, then find area of B, and then I find the ratio, right? Okay, so imagine you're walking here. Your heaven, but it means when you look up, your heaven and earth, if it is always the same, then your limits means this one, your numbers here. Integrate from what to what, right? From 0 to don't know what, let's say to 4, will be the same. But once your heaven or your earth changes, heaven is this, your roof, okay? Earth is your ground that you're walking on. If they change, then you have to change the equation accordingly. Meaning to say, you listen carefully, okay? When I walk here, right, you see my heaven, earth, same, until here, right? Until here, meaning to say that from here to here, okay, I can use the top equation, which is 6x minus x squared, my heaven minus my earth, minus the earth, which is the 2x. Okay, nothing to do with the y. Why? Because we are differentiating with respect to x. So we only look at the x. Alright? So when you walk from here to here, your heaven and earth remains the same throughout until here. Okay, so to find A, very simple. It's just this top which is 6x minus x squared minus your ground, which is 2x. Then you can simplify it lah. Later I'll show you. Okay, but I hope you understand this. Which means first of all we have to find what this value is, right? Because the guy, we only have to integrate from here to here. And is this really 0? Yes, I think so. But the equation will help us. Meaning to say that if I were to wait, look at this box, first box now, okay? This first box now. What does this first box? What's the purpose of this first box? I'm solving this and this simultaneously. Okay, your sec 2 work, and I have 0 and 4. Meaning this is 0, this is 4. Oh, that means I know that I have to integrate from 0 to 4 for the area of A, which is here. Okay? Yeah, so I hope that is clear to you. Okay, similarly, okay. I show you A first. We do one thing at a time, okay? This is related to this. Okay, I've explained to you just now already. But just to give you a big picture, this, which is this, curve minus the ground, heaven minus the earth, okay? Then you simplify, don't make any careless mistake. Okay, square, then power plus 1 divided by new power. Power plus 1, that's 2, right? Divided by 2. 4 divided by 2 is 2. Then you go and get your answer. Okay, some of you were pretty confused. I don't know whether you still are that time when I taught this. Now, this number, okay, it doesn't mean power or what. It means this number goes in first. So the 4 you sub here, put here, 4 sub here, okay? Then you get this, right? Then this whole thing, you have to minus. Now you sub in here, sub in here. But because you sub in 0, it's 0, right? So I didn't write lah. But actually it's minus 0. Okay? You go and work this out. You really need to go and try pressing calculator. Okay? A lot of students mess up here. They can get this, no problem. They mess up here, and that will mess up the whole solution. Which means you will lose 1 mark here, and you also lose the accuracy mark later. You will miss minimally 2 marks if you are not careful here. So you need to practice using the calculator, okay? Alright, now, the next one is, okay, so we have found A, right? You leave it like that. Hey, don't go and 3SF and all that, okay? Whenever they ask you for ratio and all that, you have to give exact answer. As you can see, right, later, you see the denominator 3, denominator 3, they will nicely cancel off, alright? Because if you give 3SF here, again, you lose marks here. You don't get the accuracy mark here. Okay, now, next. Okay, next one is like that. Again, I get the man to come and help us. So this man now will not be walking along this already, okay? He will have to walk along the B part, okay, so maybe I just highlight this part here, okay? This is a curve, take note, this is a curve, This is not a curve, this is a straight line, okay? And this is defined by y equals 0, right? This line here, okay? Now, what do I do now? You notice this man as he walks along this earth, okay? Heaven and earth, His heaven and earth, heaven and earth, heaven and earth, same throughout this area, okay? Until he comes to this 4. As he crosses this dotted vertical line, right? His heaven and earth changes, correct or not? His heaven has now become a curve. His earth is still the same. But because he's 变天already, right? His heaven has changed. So you need to create another integral for him. Alright? But this question that I've chosen, because today is just first lesson, it's very simple one. Your heaven is a straight line, right? Your earth is also a straight line, right? And then this one also is a straight line. So actually it's just a right angle triangle. So you can just take half times base times height, okay? But you need to find out what this is, you see. what is this? But very simple, you see, when x equal 4, then your y will be 8 lor. Correct or not? So it's just half times 4 times 8. Huh? Okay, how about this part here? So is this area of the triangle plus this part here, then that will give you the area of B already. Alright? Okay, once you've understood what I'm saying here, then this is the working. Okay, of course, firstly, I have to find out what this value is, you see. So how do I find out? Where does the curve cut the x-axis is when y equals 0, right? Set y equals 0, then I can get 0 or this. So it must be 6. Cannot be 0. Oh, how come there's a 0? Why is there a 0? Okay, there's a 0 because this curve, right, cuts the x-axis at 0 also. Okay, but that is not relevant to us. So we only take the relevant one, 4 to 6, and then you do accordingly. This is the triangle. Alright, and you can see here, I go and minus the earth. This is my heaven, and this is my earth. Alright, so it's always 天 minus the 地 lah. Can Okay, then you ding ding dong dong, then you can get an answer. Okay, this is 1, you plus 1, then divided by new power. That's why it's like that. Plus 1 divided by new power. That's why it's like that. This part here, is important. Do this one first. Sub in, you see, 6 go in first. 6 go in first. Then you put the square bracket, right? Then minus. Now 4, your turn. Your turn to go in. So the top one goes in first. The bottom one goes in second. And it's always minus. Alright, and you will get this answer. Okay, and after that, how to find the ratio? Very simple. I just press this into your calculator. Use the fraction mode. Fraction mode, and then you can get the answer already. This one, okay? This one, very simple one. That's all, finished already. Okay, so we have done one kinematics question already. I hope you are clear. Now let's go to the next question. I hope you can see everything just now. I hope so. If you can't, right, don't worry. You refer to the to the pictures I'm going to send you later. Okay, now this is the other type of question that I'm going to give you. We have done just now this one, right? Okay, we've done also this one a little bit. Now we're going to do this one. Finding y given the dy dx. Okay, this will form like one question. Alright, now you are given dy dx equal to this. So again, it's quadratic. But the curve is not quadratic. Okay, because this is the gradient function, not the curve itself. And you are given this hint. Now this is the hint to you. Hint to do what? To find your c. Okay, to find your c. This is the hint to help you find your c. Like you know your sec 1, y equal mx plus c, right? Then they say, oh, this one, then that's to help you to find your y equal mx plus c, that's c. This one is the same thing. Okay, find the value of y when x equals to 1. Okay, so firstly, just go and integrate. Okay, just go and integrate this. Of course, you see, I expand. Why I expand? Because there's no such thing as product rule in differentiation. Don't have. Don't have. So I change it into the form a, which is 1. 1x to the power of n. Not 1. Ax to the power of n. Okay? So now I integrate this. Immediately I write y. Then I write the integral and then the dx. This is the operator sign. Then now I can plus 1 to the power divided by the new power. Plus 1 to the power divided by the new power. Always must remember to put the c. So this was the c I'm talking about just now. Okay? Alright? You see, because they ask you to find y, you cannot leave your answer like that. You have to tell them, right, what your c is equals to. So that's when this is helpful. Sub in and you get the answer. Okay? and they want you to find the value of y when x equals to 1. So you give them this. Now, our class, as I mentioned, very not so strong in awareness. You see, some of you in your exam, you can underline, but then in the end, you never going to find the answer. For example, they ask you to find y now, right? Many of you, you find this, you're very happy already. That means you stop here. So always check, always check. Have I given them what they want? This is like your customer. Your customer say, oh, for my wedding, I want this. I want this. Then you must check, oh, hey, have I given my customer this? Like that. Okay, so that's all. So we have covered this already. Done. This one quite straightforward. Okay, we're done this already. Now we are going to do another question. Rather similar one, but slightly more difficult. Later, right, you will find that the one in your pop quiz, the pop quiz one, right, is even of a higher level. Because they bring in some Sec 2 work, which some of you might have forgotten. Okay, you read this question. The curve for which dy dx equals this. That means, the curve, do we know the equation? We don't know, but we know the gradient function of the curve is this one. Okay, and then they say the curve for which the pass through or passes passes. Okay, passes, that means the curve, it is the curve that passes through. Okay, not the gradient function. So your English, you must read carefully. It is the curve that passes through this. Oh, that means they're trying to hint to us this is the x and y law. This is again to help us to find c, to help us to find the c. So they want us to find the equation, meaning y equals to what, like that. Okay, so that is the whole question, same as just now. Except this one, okay lah, maybe slightly tougher, but still very easy. Okay, what did I do? I immediately change this gradient function, right, into a, which is 1, 1a x, big X, to the power of n. Okay, then what do? What can you remember how to do? Just how we went through, right? Now got the fruit, right? Got the fruit, so you must differentiate the fruit, divide by the fruit, like that. Okay, I left blanks here, meaning you differentiate by the fruit, so it's 2 lor. 2x plus 2 you differentiate, is 2, right? So normally for differentiation you have to times 2, right? Now because you are integrating, you divide by 2. Okay, then you plus 1. I cannot write here because this is a question. Okay, I had to plus 1 to the power, then divide by the new power. Then I have to plus c. Why? Because I don't know whether there's a constant there or not. This will help me to find my c. Okay, that's why they give us this. Everything that they give us is important. Okay, now if you were to work this out, you will get this. Alright, so this is the expression. Do not leave it in this form. You need to use this to help you find the c, which happens to be 0. Okay, it need not be 0, but this is a simple question. So it happens to be 0. So this is your equation. Alright, okay, now we are moving on to the next kind, which is techniques again. Okay, because we are so-called new to integration, so we have to do a little bit more on techniques, how to do it. Okay, integrate this with respect to, okay, this is a short form, with respect to x. Okay, again, please take note, there's no, why I keep on repeating, because common mistake over the years, right? Students see this, they go use quotient rule. There's no quotient rule in integration, don't have. So what do I have to do? When I see this, right, I have to change it into the form that I can do the reverse process of, meaning a x to the power n, a x to the power of n. Then I can integrate. Okay, so again, it's plus 1, same old story lah, same old story. Okay, these are very simple thing. Plus 1 divided by this, plus 1 divided by this. Differentiated fruit, you differentiate x is still x, also 1. I didn't write lah, no need to write. Okay, but you need to remember, meaning for this kind, right, for this kind, students always forget the 2. Alright, so tell yourself now, at least 3-4 times, right? tell your brain you have to remember the differentiated fruit. Okay? And then you end up with a plus C. In this case, they didn't give us any clues on how to find the C, so we leave it as such. Alright? Now I'm moving on to the next thing already. If I can't cover what I want to cover today, I will just stop, okay? I will stop exactly at 45. We must respect time. I will not extend. Find y given that... Okay? Now, this is just slightly harder, okay? This one is nothing, it's just a page number, okay? Nothing to do with the question. Now, find y. That means, again, you want to work backwards lah. But again, I told you there's no quotient rule, whatever, product rule for this integration, right? So you need to know that there is a difference of two squares here, so algebra must be strong. And then this, when you divide by this, is this. This, when you divide by this, and that means you bring up, you will get this. Yeah, so now it's so much simpler than this, you see. So your algebra must be strong. And then when I integrate this, it's just y. Integrate this, it's just like that. Alright, so that's all for today. I mean, not saying all for today, I haven't finished yet. Sorry, wait. We are just doing these simple ones. Then to find the C, right? How to find the C? It's to use this. You sub in x and y, right? You can find the C already. So that's all. Okay? Yeah, simple one. Okay, now let me go to the next thing. The next thing is this. The next kind of question, right? Is this kind. Part 1, they ask you to differentiate, right? Then part 2, they will say hence. So we have done this before also, okay? So now it's about practicing them, okay? So you see, first part asks you to differentiate. Second part, this one, okay? Now, first part, I believe majority of you no problem lah. You see, this one you can use product rule. You can, you know why it's differentiation. Yeah, so you have to be very clear what you're doing. Don't panic when you see the exam question. You see already, oh, differentiation can. Product rule. Differentiate this one don't touch. Okay, now this one don't touch. Differentiate this. Now a lot of you the first part no problem, but the second part, right, you always forget to write this, So may I recommend you use the method that I always teach you again. Differentiate this one don't touch. Okay? Now you write this first, differentiate, no, this one don't touch, differentiate this. Can? Because some of you, you differentiate this, then after you differentiate, you're so happy, right? You forget to write this, you see? So you go in this order, left to right, then you won't miss out anything, okay? Because our eyes are trained to go left to right since young. Okay, then after you've done this, you write in this form. And then as you can see, right, why I choose to write finally, finally, right, why I choose to have this as the denominator, because I look at the second part, I notice that this is my denominator. That's why I didn't leave it as this. I combine these two by multiplying both the numerator and denominator by this, and then I get this here, okay? Then I combine the top and I get this, right? Then I stop here. Okay, I stop here. But normally class, in the O level, they will guide you. They will say, oh, show that dy dx of this is this. They're very nice one. They will ask you. But in our normal practice, we will give you tougher ones where you need to use a bit more common sense. Okay, now after this, okay, this is the important part. Please try to use this method, okay? Because some of you will choose to use your own method. Now, you're asked to evaluate this. Do not start from here. Whenever students start from here, right, they get stressed out because it's hard to see what to write for the next side of the equation. That means the right-hand side of the equation. So what you do is always, after you have found this, right, start from here and then say that integrate this is this. Correct? Because I differentiate, I get this, So I integrate, I'll get this, right? So this is what I've written here. I integrate this, you see, I integrate this, I will get this, my original one. Okay? And class, I recommend you don't write y here. You straight away look at the question, right? And then you straight away start already. You know why? And then you when you do such things, you go back to this. Because some of you will have transfer error. That means you write here, you copy the question wrongly. Then very yin wang all wrong already. Okay? Sometimes they give you error carry forward. Sometimes they don't. Depending on how well the paper is done. Alright? Okay, so for this part, right, this will give me this. Okay? But you see, now you see, oh, there's a 1 and a 6, right? Then you must follow them. There's a 1 and a 6, you must follow them. So I put a square bracket like that. 1 and a 6. How come no need to put plus C? Oh, sorry. Sorry, I was saying just now you must put 1 to 6. Why? Because the question comes with a 1 and a 6. 1 and a 6, right? So 1 and a 6 here, you must have 1 and a 6 here. Clear? Okay, why don't I need to put a plus C? Because this is what we call definite integral. That means you will get a definite answer. That's one way you can look at it. And then there's no need to know the C value, the constant value, because this C minus this C, when you sub in the 1, the C will be cancelled off. So don't bother to write the C. And don't need to find the C also, okay? Now, let's see here. Okay, so I integrate this, I get this, right? But you must see, have the N in mind. Is this the same as this or not? They are not the same. So you have to manipulate this until it becomes this. So this is a test of your power observation. You take a look. Denominator same, very good. And actually you can combine these two together to become 6x plus 4, right? And if I times 2, I'll get this. Times 2, I'll get this. Oh, that means I just need to times 2 here, and that's my answer. Okay? Because later I can rewrite as this. Must write this. You don't assume the examiner know that this is equal to this, okay? You must really show them as if they are really clueless people, don't know maths at all. Okay? You must step by step show them that this is this. Okay? Meaning to say, you must write what they want you to find. Then now you have a 2 here, okay? You can do your question already, no problem. Okay, now you will notice that once I put in the 6 here, right? Then why I didn't bother to do the other one? Because 1 when I put inside is 0, so I didn't bother to write it's actually minus 0 inside here, okay? But you can write just telling you that actually I've chosen a very easy question for you, today's first lesson only. Then that's your answer. Okay, no problem. Oh, I forgot to tell you just now all the area one, right? Area, undergraph and all that. You need to put unit square. Okay, square units. But because just now we were finding ratio, right? So I didn't emphasize. But for such questions, okay, you don't put, okay? Because this can mean something else. It can represent another quantity which is not ratio. Alright, now I run out of time. I'll stop exactly at 45 so that you have time for your other subjects. So we have covered today this one, okay, this one, and this one. We have not had the time to cover this one. Never mind we'll do it tomorrow. I don't know whether tomorrow there's lesson for us. I think there is. So what I need you to do now, right? If you can, go and do this 16.1, which I've distributed last lesson, which was yesterday, right? Okay. Chapter 16.1, indefinite integrals. Okay, 15 minutes. 15 minutes. Is it chapter 16? Okay, I think there might be a typo error here, but never mind, don't care. You just try and do this, okay? Try and do this. Now, this question, you try and link it to whatever we have gone through. You ask yourself whether it is this type, or this type. Okay, because your exam question is categorized into either this, or this. Okay, so if you are able to, whenever you do questions, then you see, oh, is this one, 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 then you will find that every exam, every prelim paper that I give you is around here. Okay, of course there are some other stuff I will tell you as the time goes by. Okay, now we have run out of time. I will go through these solutions tomorrow, so you just do this. I think it's enough. Okay. Okay. Thank you very much. Anything, please PM me. Anything you don't understand about this, you just this lesson, you just PM me. Thank you very much. Bye bye.